Good afternoon, everyone. In my presentation, I'm going to show how using element anomalism in a hydrothermal system can map out a new exploration target in a previously explored belt. The East Laverton project has been previously explored for nickel and gold. CSA has identified a VMS signature in excess of 20 kilometers from drill data. This presentation will show how letting the data speak for itself rather than being model-driven can identify a more likely target. First, I want to thank St. George for permission to present this data set. The work being presented is from an interpretation completed by CSA and is currently being used for targeting purposes by the company. This is an interpretation of existing and historical data with all the data already in the public forum. No previously unreleased data is being presented, but the data might look a little different with the additional of historic work included that hasn't been in the digital state yet. The East Laverton project is located on the eastern margin of the Yilgarn Craton and has thick Permian cover increasing to the east. Just right there. Extensive nickel sulfide exploration identified thick intervals of ultramafic along the Stella Range in the west from Cambridge to Aphrodite. The project was a focus of exploration from 2010 to 2016. Unfortunately, little to no economic mineralization was present. Gold exploration has been predominantly in the central and eastern areas, including Bristol, Athena, and Oxford. There has been difficulty associating the near surface and weathered mineralization to a bedrock source. The aim of this project was to complete a lithostructural interpretation, as can be seen here on the right, and combine it with the data assessment based on a geologically validated database to determine if additional targets are present. Part of this work included the addition of historical data from WAMX. A majority of this data is from the 70s and 80s. It was a wealth of geological detail, but it was in a very painful paper format. From this historic data, we were able to confirm the presence of greenstone. From this data set, we were able to confirm the presence of greenstone further south than previously interpreted, all the way down in through here and increased in width from the GSWA data sets. Another significant highlight of this work is the element anomalism that is based on the Lithogeochemical classification. As a result of this process, numerous targets were identified with anomaly maps generated in line with the mineral systems approach. I'll get it right at the end. By using a mineral systems approach, the data speaks for itself rather than trying to fit into a particular deposit-style box. Since the majority of the data set was targeting a nickel sulfide model, the data being assessed may not be in the best location for assessing the size and the true extent of a hydrothermal system, but it'll give you an indication of the presence of fluids and the size of the system. This is important as economic hydrothermal deposits have large element and alteration halos on a kilometer scale. The lithogeochem interpretation presented here is focused at the camp scale, so we're through here, as I was able to identify prospective rock type, magma series, as well as alteration and metal anomalism. As a part of the project, significant surface data was compiled. A bulk of this data is of WMC, Plutonic, and Dominion vintage. As you can see on the left, significant zones of gold mineralization are present. The story on gold isn't finished yet, but where it has been drill tested, it has been underwhelming, as you can see on the right. And this is desurveyed gold with the highest value plotted near surface. What is also significant is that not all historic surface anomalism has yet been fully explored. And there are a few targets, but quite open space. The interpretation presented is focused on the drill hole database and multi-element anomalism buried in the data. As I present an overview of this data, I want to stress that due to the nature of historic data, there are multiple and unknown analytical methods present, and that I am treating the data based on anomalism and not hard numerical values. All samples were geochemically classed as fresh before any interpretation, and no weathered material is included in any of these anomaly maps. Also, lithology was classed first, and these attributes were subdivided to assess alteration. Once alteration was identified by lithological type, element anomalism was assessed, resulting in a complete queryable dataset. This resulting dataset has defined for each assay a lithological type, alteration, and any anomalism present. The classification of lithologies was done on fresh data. In this data, there are over 25,000 data points with enough multi-element data to classify individual magma series and rock types. Using numerous bivariate plots, lithologies were classed based on their unique geochemical signatures. The geochemical classification was classed against lithology, which assisted with determining sediment horizons, particularly black shale. So of a significance in this data set is the green to blue, which is your mafic horizons, and your pink to red, which is your calc-alkaline andesitic horizons. On the western side of the project, 2 mafic series are present, with one trending towards more calc-alkaline. For the purists in the room, there's very little thorium-niobium data available on this project, and what little data is present does support 2 magma series, which I have identified. On the eastern side, a mafic unit with significant ilmenite fractionation, as you can see on this vanadium-titanium plot, is part of a tholeiitic magma trend. This trend is marked by the red through orange and yellow, and moving into a more tholeiitic zone. The second magma is of calc-alkaline composition and heads down towards this direction. A comparison of the western and eastern sides of the East Laverton project show a main magma trend on this Jensen cation plot. On the western side, a significant amount of anomalism is associated with the unit basalt 2, which plots here. I will identify this prospective horizon going forward. On the eastern side, the magma bifurcates, not really, but on the map, it bifurcates into a tholeiitic magma in the same area as the western data set. The change is marked by a significant ilmenite trend. The remaining data in the eastern side remains along the calc-alkaline trend. It's really frustrating. Moving on to alteration, the distribution is widespread. All alteration was classed based on individual lithological types. For example, the alteration box plot from large shows a significant alteration trend from least altered up through to sericite chlorite, all the way up to sericite, which I've termed trend 3. There are additional diagrams and processes that I have not shown here that support this interpretation. The map shows the spatial distribution of alteration associated with mafic, intermediate, and felsic lithologies. Note the significant chlorite, sericite dots, which is all the yellow and orange, and that's been overprinted by my perspective horizon through here. The ultramafic and sediment lithologies are not included on this interpretation. In particular, the presence of mineralized black shales was separated out. This perspective horizon that sits all the way through here, this zone of alteration extends for 20 kilometers along that horizon, which is the same as that basalt 2 that I identified in that previous plot. The anomalism present is difficult to correlate due to multiple vintages of data and methods. Due to the lack of coherent data, element anomalism was determined using crustal background values with the understanding that anything over 10 times background is significantly anomalous. The figure by Scott Halley shown here may model a porphyry system, but the theory applies across all hydrothermal deposits. Using the crustal abundance for a given element and assessing based on the degree of anomalism, the distribution can be mapped and used as a vector into prospective areas. The temperature gradient starts with molybdenum in the core working out towards arsenic and thallium out in more distal positions. Based on this approach, a significant distribution of elements associated with the VMS signature is present at East Laverton. In each of these element maps that I'm showing, so I've got zinc, cadmium, silver, tellurium, tin, and thallium. The blue represents values that are at either detection or at crustal abundance. Yellow is from crustal abundance to weakly anomalous, and anything that is red is 10 times crustal abundance. Note that there is a very strong correlation between zinc and cadmium. This trend of zinc and cadmium is also over a 20-kilometer strike that correlates with the alteration. Just for the people who can't read in the back, the zinc goes up to 1.45% in mafic lithologies, and there's silver up to 19.4 grams. Anomalous thallium, which some of you may not know, is considered indicative of galena and sphalerite at values greater than 1,000 and 5,000 ppm, respectively, and values in this belt have exceeded over 5,000 ppm. Also, arsenic, lead, moly, and bismuth are also anomalous in this area as well. Note the arsenic is very similar to the zinc and cadmium trend, as well as there's significant lead present. The scales are the same. Blue is basically below crustal values, yellow is almost anomalous, and red is significantly anomalous. The combined spatial association of these 10 elements is consistent with the VMS signature. On the western side, the 20-kilometer trend of anomalism can be seen in bivariate plots with a significant positive correlation with cadmium and zinc. So I've got cadmium and zinc logged, plotted here, and cadmium and silver plotted here. Tellurium also shows the same thing, but it doesn't have as abundance of data. Also note that the color here correlates to the colors on this map, and the yellow is molybdenum, which would be your center or the hottest part of your system, moving out towards your more distal rocks, and that is where your strongest anomalism actually sits and correlates beautifully. This anomalism is along the same horizon as the chlorite-sericite alteration. And this is the perspective horizon, which is also linked to basalt 2. I want to acknowledge that there are gaps in this data between this anomalism down here at what was drilled as Aphrodite and up here towards Windsor, and this is about 15 kilometers of stratigraphy that has absolutely no drilling and potentially could be anomalous as well, which would make this mineralized, or this hydrothermal signature over 35 kilometers in strike. To summarize, the main VMS anomalous areas are associated with a mafic lithology, chlorite-sericite alteration, and at least 10 anomalous elements. It is also worth noting in the data that the gold values on their own are not part of the story, but their areas of concentration in combination with the hydrothermal anomalism highlight the prospective VMS areas. So particularly in this area here, there is bits of gold present, and this correlates to your strong zone of alteration and strong zone of element anomalism. So what is the treasure? Previous exploration did not identify the significant VMS trend, as it was not the primary focus. This shows how model-driven exploration for nickel missed a likely VMS hydrothermal system. The data set may not be geared for VMS targeting, but there is enough information to determine a signature at a camp scale. This adds value by identifying areas to follow up on rather than starting again from scratch, or simply walking away from a project with a potentially significant system hiding away in your data. Thank you.